In this video, we're going to learn how to name ionic compounds with polyatomic ions in them. So these type of ionic compounds are called ternary compounds, ternary ionic compounds. And so a ternary ionic compound still has a metal in it, but it also has something called a polyatomic ion. Here's an example of a ternary ionic compound, MgCO3. You can see there's a metal here, but then there's this weird group of atoms here. Normally, a binary ionic compound has two elements only, like MgCl2, that's binary. Metal, non-metal, that's it. But here you have metal and a group of atoms here. And that group of atoms, that's called your polyatomic ion. It's a group of atoms bonded together, and they carry an overall charge. And what's interesting is that many of the polyatomic ions, you have them because they end in ate or ite. There are some exceptions like hydroxide, ammonium, cyanide. Those are polyatomic ions. On their own, a polyatomic ion is not really considered a compound. It's only a compound once you put the ion with a metal or some other ion. So here are some examples of polyatomic ions. This is CO3 2-. It's carbon, 3 oxygens, and overall there's a charge of 2-. Ammonium over here, NH4, and then charge of +1. Acetate, CH3COO-, or you could write it this way, like 2 C's, 3 H's, 2 O's, with a charge of -1. Phosphate, PO4, 3-. Hydroxide, OH, 1-, right? When there's 1-, you don't have to write the 1. SO4, 2-. So those are all different polyatomic ions here. And you can see a lot of them end in ate or ite, with some exceptions like hydroxide here, cyanide here, ammonium as well. Take a look at the charges. Try to make a little observation or comment about the charges. Hopefully you realize that most of them are negative charges. There is an exception, ammonium being a positive charge. So ternary ionic compounds are ionic compounds that contain a nonmetal or a metal and a polyatomic ion. So here we have the ternary ionic compound made up of calcium and then the polyatomic ion CO3, carbonate. So the first step you need to know how to do is to decide if a compound contains a polyatomic ion or not. And you can do that by formula or by name. So if you take a look over here, we have a bunch of different compound names, and we have to decide if there's a polyatomic ion in it or not. Now you are given a reference table. Your reference table will look something like this over here. And in that reference table, usually at the back of your periodic table, you'll have a list of polyatomic ions. So you can see the names here, and you can also see the formulas here, and you'll notice the atoms are in brackets, and then the charges are outside the brackets, and that'll be important later on. But whenever you want to know the name of a polyatomic ion, you can come to this table and take a look. So here we have basically all the ones that end in -1 for their charge, all the ones that have 2- for their charge, all the ones that have 3- for their charge over here. So you can take a look at those names. So let's go here. I'll do 2 examples with you, and then you'll pause the video and try the rest on your own. You'll see here we have sodium nitride. Now this doesn't end in ate or ite, so to me I don't think it's a polyatomic ion. It's not the exceptions hydroxide, ammonium, or cyanide. This is just regular nitrogen. So this does not contain a polyatomic ion. This nitride is just the N3- that you do a crisscross with. So actually that's the formula. Nitride is the ion, so there's no polyatomic ion. We have nitride, and it's N3-. So this is not a polyatomic ion. It's just a regular ion from the periodic table. Next, sodium nitrate. Notice it ends in ate, so that would mean that there is a polyatomic ion in there, yes. The polyatomic ion is nitrate. If you go to your reference table over here, you'll see nitrate is NO3 with a -1 charge. So we can write NO3 with a -1 charge. So pause the video, try the rest on your own. Let's take a look here. We have calcium, it's just a metal. Chlorate ends in ate, so yes. The polyatomic ion is chlorate. And we can see it's ClO3, 1-. That's from the reference table. Okay, this one's interesting. Ammonium chloride. So you look at the second name, chloride. That's not chlorate or chlorite. It's not hydroxide or cyanide or ammonium. So second one is not a polyatomic ion, but the first one is, because it's ammonium. And so I expect you to know ammonium is a polyatomic ion. And we have NH4 plus 1, or 1 plus. Potassium is not a polyatomic ion, it's just potassium, but hydroxide, it doesn't end in ite or ate, but it is that exception, hydroxide. So yes, it is a polyatomic ion. It's hydroxide. It's a very common one we're going to see a lot of in grade 10. And so it's OH minus or 1 minus. Aluminum sulfide. So aluminum is a metal. Sulfide, it's not ite or ate. It's not hydroxide or cyanide or ammonium. So no, there's no polyatomic ion here. We just have the regular sulfide ion, which is a regular sulfur with a charge of 2 minus that you'd see in your periodic table and you do crisscrosses with. Beryllium sulfate ends in 8. So yes, there is a polyatomic ion. It's sulfate. In brackets, SO4, 2 minus. Lithium chlorite. Ite, yes, that is a polyatomic ion. And then chlorite is the name of the polyatomic ion. It's not chloride, it's chlorite. So we'd have ClO2, 1 minus. So that's your first step, being able to identify that a polyatomic ion exists in your compound either by name or by formula. By formula, it's pretty easy. You can see there's a group of atoms here, and that group of atoms consists of the polyatomic ions. And by name, you just have to look at ite or some of the exceptions. So what I recommend you do is you take a look at the slide deck that's in your notes or even here, and you try to guess how to name compounds of polyatomic ions. Look at the trends and patterns. You have sodium nitrate, calcium chlorate, ammonium chloride, potassium hydroxide, beryllium sulfate. You'll see the rules are pretty straightforward, so try to make a little bit of a guess, make some list of steps, and then we'll go over it together here to make sure you're on the right track. So if we take a look here, we're going to name this one. We're going to start off with the naming. We're going to have KNO3. We're going to have to name that. So ternary compounds are pretty straightforward to name. All you have to do is name the first element. So in this case, the K is potassium. The second part is you have to name the polyatomic ion. So you have NO3. You go look in your table here and you find NO3. Look at what's inside the bracket. It doesn't really matter what the charge is right now. Look at the NO3. It's not NO2, it's NO3. So because it's NO3, we know that's nitrate. So that means that this is simply potassium nitrate. We don't change the ending of the polyatomic ion. You just name them as you see them. And that's why they're a bit more straightforward, because there's no rule where you have to change that ending of the polyatomic ion. So you try to name CaSO4. Pause the video, try it yourself. So now you've unpaused the video and you're checking your work. The metal is calcium, so we know it's an ionic compound because there's a metal there. And it's a ternary one because there's a polyatomic ion, SO4. If you look in your chemistry reference table, you'll see that SO4 is sulfate, so calcium sulfate. For practice, you can try the following table here. So pause the video, try it out, and then we'll take it up. So at this point, you've paused the video, and you've tried the problems, and now you're checking your work with the key here. So we have CaCO3. You'll notice I broke this table up into a series of steps, but in reality, you could just do it in one step. So we have the metal is calcium. I'll start off by doing it in 2 steps, and then afterwards I'll just do it in 1 step. The polyatomic ion is CO3, so that's carbonate. So we have calcium carbonate. All right, now we have Al2CO3. Oh, there's a mistake in this one. This should be Al2CO3, like that. That's an error. We'll have to fix that. So this here would be aluminum So aluminum, that's the metal. And then we have carbonate. Over here we have sodium is our metal. OH is our polyatomic ion, so hydroxide. Over here we have magnesium as our metal. And then OH is our polyatomic ion, so hydroxide. Now this one's interesting. It's a bit different. Your polyatomic ion's in the front, so you would have ammonium as your polyatomic ion. That's your NH4. And then bromine becomes bromide. So you still do have to change the ending if they're not polyatomic ion for your second one. So just be aware of that. Here you have aluminum and then NO2. So be careful there. Aluminum is your metal. And then your NO2, if you go to your chemistry reference table, you have NO2 and NO3. So look at what's inside the bracket. The NO2 is actually nitrite. So be careful there. It's aluminum nitrite, not nitrate. Here we have, two polyatomic ions. We have ammonium, and then SO3 is not sulfate, but sulfite. Here we have similar compound. Notice one oxygen different. That makes it a different compound altogether. So that's ammonium sulfate. And then lastly we have Mg and then the CH3COO. Now you could have written this as Mg C2H3O2 because you just combine all the atoms together. It could have been written that way as well. So this is magnesium, that's our metal. And then this here is a polyatomic ion acetate. And so now we've named a variety of ternary ionic compounds using the naming rules. In the next video, we're going to take a look at how to name ternary ionic compounds, how to write formulas for ternary ionic compounds from their names.